Today we're going to start graphing with rationals. And in order to start that, we'll talk about the transformational ones first. And so with transformational, there's two parent functions that we learned, the 1 over x and the 1 over x squared. Rationals, a fraction, so that's the reason why these are called rationals. The x is in the denominator for it to be a rational. And here's our two parent functions shown on the graph. Our rational odd, which is 1 over x, has one piece in the third quadrant and one piece in the first quadrant. The key point there is 1, 1, and then the other key point is -1, -1. If we think about putting 0 in the place of x right here, we would get 1 divided by 0. You cannot divide by 0. That makes it undefined. So that is my vertical asymptote, what makes that denominator 0. So my VA here would be x equals 0. And it is x equals because it's a vertical line. So you have to have the x equals there for the vertical line. And so that's this y-axis right here. That's my vertical asymptote. My horizontal asymptote is also 0 because since there's a 1 in the numerator, there's no way that it could ever be 0, since the only way to get 0 is if the numerator was 0. So it jumps over this line right here. So this is my horizontal asymptote at y equals 0. So the horizontal asymptote is at y equals 0 on both of those. Now what an asymptote does is it guides your end behavior. So as it gets closer and closer here to our asymptote, it's going to get closer and closer, but never touch. And then it will follow that forever. So our domain is all real numbers except for 0, and our range is all real numbers except for 0. For this one here, because of the square, the negative x values, negative times a negative turns into a positive. So both of them are above the x-axis, since y will never be negative. So our range for this one is from 0 to infinity. Notice that there is a parentheses there. That is because it is not touching 0. Remember, that's guiding it, but it's never going to touch it. And then our domain is all real numbers except for 0. If we wanted to talk about the end behavior of this, we would say as x approaches negative infinity, which we said is the left, if we look at our left end behavior here, it is getting closer and closer to 0. So it would be y approaches 0. And as x approaches positive infinity, y is also approaching 0 because that's what's happening on the right. All right, now that we talked about our two parent functions, let's try graphing them so that you can see with the transformations. This right here is in the place of d, so that would be down 3. And then in the place of c is this 4, and so this would be left 4. Remember, when it's an x plus 4, it's going to go to the left. If it's x minus 3 like this, it's going to go to the right 3. All right, so we're going to move this graph down 3 and to the left 4. What we do here is we take our asymptotes and we take everything and we pick it up and we're going to move it to the left 4 and down 3. That means that this would change our horizontal asymptote, and this one here would change our vertical. Because if I move the horizontal asymptote left and right, that's not going to matter because the horizontal line goes on forever, left and right. So my new vertical asymptote would be at -4, since that's what's going to make that 0. And since it moved to the left 4 from the y-axis. So here is our new vertical asymptote. And that is at x equals -4. Our horizontal is going to move down 3. And so it is going to be at y equals -3. Now, for the rest of our points, we're going to do exactly the same thing. So our key point was at 1, 1 here. I would move it to the left 4 and down 3, and it is right here. And so our other point would be down here, and we would move towards the asymptotes. And so our domain would be all real numbers except for -4. It is jumping over -4 because that is the one that makes it undefined. And our range would be all real numbers except for -3, because that's the one that is jumping over for the horizontal asymptote. If we talked about the end behavior for this one, as x approaches -infinity, y is approaching -3, because it is getting closer and closer to this asymptote right here. And as x approaches positive infinity, y is also approaching -3, because it is getting closer and closer to the asymptote on this right side. We'll do one more with a stretch or compression so that you can see that one, and I'll do that one with the other parent function so that you can see that one at work. So here is our other parent function. That's left 1, down 3, and we have a vertical stretch by 2. Remember, vertical stretch by 2 looks like we're taking it here and pulling up and down. So we're going to stretch it vertically. All right, so the first thing we want to do is look at those asymptotes. It went to the left 1. So my new asymptote is going to be right here at x equals -1. The asymptotes guide your behavior, so you really want to graph those first. And then it's going down 3. So there is my horizontal asymptote at y equals -3. Now our key point on that one was also 1, 1, but it's been stretched by 2. So instead of being at 1, 1, it would be at 1, 2. I'm not changing the x value because it is a vertical stretch. So I have vertically stretched it by 2. Then I move it to the left 1 and down 3 units. And it would be the same thing on the other side. So we've taken it this way and we've stretched it. Notice that it's further away from the asymptote. So it's going to have more of a gap right here. That's what that vertical stretching does. Oops. I just graphed the other parent function. Sorry about that. So it's going to be on this same side here. Made a mistake there. This was the squared parent function. Should have been paying attention. So that's the one that's got the 2 above the asymptote. And so our domain for this is all real numbers except for that -1 that it's jumping over. And then our range is all of the values above the asymptote. And the asymptote's at -3. So that would be from -3 to infinity. Again, with a parentheses because it is not touching that asymptote. So that was a quick review of rational functions with transformations. Now we're going to talk about what happens if it's not in the transformational form, because that's the only time we can use transformations is when it's in that transformational form. If it's not there, then there's other rules, and that's what we're going to focus on now. A rational function is one, again, that looks like this in the form of a fraction. P of x is the numerator, Q of x is the denominator. When we look at these, we still want to see what is going to make that denominator 0, since it will make it undefined. In order to do that, you're going to have to factor. Remember, factoring is our friend in rationals. So we're going to factor out our greatest common factor of x, and we're left with x times x minus 5. Now this x and this one can cancel out, but we still have to take it into consideration with the domain restrictions, because if it was 0, it would make this whole thing 0. So our domain cannot include 0, and it cannot include 5, because 5 minus 5 would make that 0. Again, with this one, I would want to factor. If you have not gotten good at factoring, make sure you're practicing and getting really good at it. X would have to be unequal to -3 and 1 here, because that's what's going to make those denominators 0. Now to the rest of this graphing. So here is our asymptote information. F of x is P of x over Q of x, just like we said up there. And it should have no common factors, so we will simplify those. For the vertical asymptotes, the graph of f of x has a vertical asymptote at each real 0 of Q of x. So at every point where the denominator is 0 and makes it undefined, that's going to be my vertical asymptote once we have reduced it. So we set the denominator equal to 0 and solve for x. So the vertical is a little bit easier. You take that denominator, set it equal to 0, whatever makes it 0 is your vertical asymptote. For the horizontal, there are 3 rules listed here. If the degree of p of x, which is the numerator, is less than the degree of q of x, which is the denominator, then y is equal to 0. That's the horizontal asymptote. Last year we called that BOBO, bigger on bottom, 0. So if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is greater than the degree of the denominator, then the graph of f of x has no horizontal asymptotes. So that is botno, bigger on top, no horizontal asymptote. So that's if the degree of the numerator is bigger than the degree of the denominator. The third rule says if the degree of the numerator equals the degree of the denominator, then y equals a over b is a horizontal asymptote, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. We called that one eats DC. Exponents are the same, divide coefficients. So we said the rules for horizontal asymptotes is Bobo Botno eats DC. Bigger on bottom, 0. Bigger on top, no horizontal asymptote. Exponents are the same, divide coefficients. All right, so the rules for sketching the graph is there on your notes, so you can read through those. We're going to go ahead and look at an example so that we can run through it together. We're going to go ahead and start with an easier one. So we're going to start with this x plus 2 over x minus 1. This is not in the transformational form, so it is not going to the right one. It is not doing any of that stuff because it is not in the transformational form. So I have to apply the rules here. We said for the vertical asymptote, it's whatever makes this denominator 0 once it is reduced. This is reduced. You cannot cross those x's out. So this is as reduced as it gets. So my vertical asymptote would be 1. 1 minus 1 is 0. So this is x equals 1. That means that my vertical asymptote is going to look like this. I'll go ahead and graph that first. At x equals 1. And it must say x equals 1 because that's what the equation of a vertical line is. For our horizontal asymptote, we need to look at the degree of each, the numerator and the denominator. So the exponents here are the same. They both have an exponent of 1. So this would be eats DC. Exponents are the same, divide the coefficients. Our coefficients happen to be the same here too. There's nothing in front of the x and nothing in front of the x, so we know the coefficient is 1, and 1 divided by 1 is 1. So our horizontal asymptote is at y equals 1. Now, from this point to graph this, you cannot just find key points because it's not in the transformational form. We would make a table of values. And you want to pick points to the left and the right of this vertical asymptote. You're going to create a table of values. You want to stick to both sides so you can see where your rational is at. So I'm going to definitely go to 0, and then I'm definitely going to go to 2. 0 will be the y-intercept, so that will answer this question. In order to find the x-intercept, we need to solve for this top part to be 0. So we would take that x plus 2 and set it equal to 0. I subtract the 2, x equals -2. So there's my x-intercept at -2, 0. We would want to use that point as well. So we've got 1 point there so far. When I plug in 0 for both of these, that's 2 divided by -1, which is -2. When I plug in 2 here, I get 4 over 1, which is 4. So now I'm going to graph both of those. And I just discovered I made another mistake. Sorry about that. I graphed 2, 0 instead of -2, 0. Wish there was someone to catch me here while I was doing that. Here's x equals -2. And I wrote -2, but then I graphed +2. So please fix that. It is -2. Now that I have those points, that's really enough for me to graph. Because the asymptotes guide my behavior, I can use that to graph my line now. I just move towards the asymptotes. So I graph towards the asymptotes, and there is my rational. We said the y-intercept is at 0, -2, and the domain is all real numbers except for that +1. If we were looking for the range, it would be all real numbers except for that +1 as well, this horizontal asymptote. If we were looking for the end behavior at the ends, it is approaching 1. It is getting closer and closer to 1. All right, we'll try something a little bit harder now. So I'm going to go down here to this bottom one. I factor that bottom, and we get x over x minus 3, x plus 1. Now we're ready to answer all the questions here. In this case, there are two things that would make our denominator 0. That means I've got two vertical asymptotes. 3 minus 3 would be 0, and 0 times anything is 0. So my vertical asymptote is going to be at 3, and then I'm going to have a second one at what makes this 0. And in this case, it'd be -1 plus 1. So I've got 1 at -1 and 1 at 3. This is a good time to tell you, you can never cross a vertical asymptote. So it will never cross a vertical asymptote. In some cases, though, it will pass the horizontal. It won't pass it on the sides here, but it can pass it in this middle section. So keep that in mind. All right, for our horizontal asymptote, this is bigger on the bottom. When we look at the exponents, the one in the denominator is bigger. So this is Bobo. Bigger on bottom, 0. So my horizontal asymptote is y equals 0. There it is. All right, now we're going to have to figure out what is going on this graph. We can start by doing the x-intercept and the y-intercept, especially the x-intercept. That's whatever makes my numerator 0, because 0 divided by anything is 0. So in this case, that's easy. It's 0, 0. Because I would plug in a 0 here, that would make my numerator 0. So that's an easy one to graph right there. In this case, I know it's going to cross the horizontal asymptote, since that point is on the horizontal asymptote. All right, for the rest of our points, we're going to make a table of values. And we said we wanted a point to the left and right of the asymptote. So if we have two asymptotes, that means we want 2 points. So I'm going to pick a point to the left here. And so that's -2. So I'm going to put that on my table. I'll pick a point to the right. We've already found that one, so I'm going to go ahead and pick another one to the right. So at 1. Then a point to the left of this one would be 2. And then to the right of this one would be 4. So I'm going to have a few more points here just to make sure I know what's going on this graph. We go ahead and plug in the -2. It's easier to plug into this one. So we would get on this first one, -2 over -2 minus 3 is -5. And that is being multiplied times -2 plus 1, which is -1. So that is -2/5. So I would go to -2, and -2/5 is like right there. It is a decimal value between 0 and 1, so anywhere close to that is good enough. Then we would go ahead and plug in the 1, plug in the 2, and plug in the 4. I'm going to go ahead and fill out my table. Now that we have our table filled out, we can go ahead and graph these points. So it tells us that 1, it is at -1/4. So I'm going to go to 1, -1/4 right there. At 2, it's -2/3. Still between 0 and 1, so I'm just putting the points there. Then we've got at 4, it is at 4/5, so that's above right here. It's still not close, not above the 1, it's still between the 0 and 1. And so we're ready to graph our quadratic or rational here. You could get fractional points here. You could get all kinds of other points. If you felt like you needed more points, you can just build this table as much as you think. For the y-intercept, we already found it. It's right here on 0, 0. We said it was crossing that horizontal asymptote. And so if we guide this through to the asymptotes, I'm going to have a piece on this side, a piece over here, and then we've got our third piece in the middle. And so to be guided towards the asymptote, we get something that looks like this. There is our rational. Again, this one crossed the horizontal asymptote in between our two verticals, but then towards the end behavior here, they're both moving towards 0. So this cannot be -1 or 3. Those are the two vertical asymptotes that it's jumping over. All right, we'll try one more hard one, or harder one. It's not that hard. We've got x plus 3, x minus 1 here, and then x minus 2, x plus 1. None of those are the same factors, so nothing is going to cancel out. Now we're looking for our vertical asymptotes. The vertical asymptote on here, we'd have 2 again. What makes our denominator 0 is 2 and -1. So I'm going to graph those, 2 and -1. For our horizontal, we apply the rules. And so this is an eats DC again. Exponents are the same. We divide our coefficients. So our horizontal asymptote is at y equals 1. So we've got that right there. To find our x-intercept, we set our our numerator equal to 0. Because that's what's going to make y 0. If this numerator is 0, that's going to make our y value 0. So in this case, we would have 2, -3, 0, and 1, 0. So 1, 0, and -3, 0. That gives us 2 points to start. To find our y-intercept, that's where we're plugging in 0 for all of our x's. And so that gives us 3/2. That one's easier to plug into this one because 0, 0, 0, 0 makes all of that go away. So we get -3 over -2, which is 3 over 2. That's 1/2. So at 0, I'm at 1/2. This is again crossing that asymptote because this point is above it, this one is below it. So we know at some point it is going to cross. We do need another point or so to graph this. We've already got a point to the left of the asymptote, so we already know this side is going to look like this. On the inside here, we have 2 points and one's above the asymptote and the other one's below it, so we already know it's going to cross. So it's going to look like this. We don't know what's going on over here. So we need at least the 3. You could get more points if you felt like you needed to, but at least the 3 there so that we can graph it. So we're going to go ahead and graph 3, 3. And then move it towards the asymptotes, and there is our graph. These are cool kind of graphs. It's got 3 pieces on there. X has to be unequal to 2 and -1. Those were our vertical asymptotes. It was jumping over those points. If we talked about the range in this situation, it would be all real numbers. Because even though this graph is jumping over to this one above it, and it's skipping over that 1, right here, it is 1. So this middle section takes care of that all real number. So our range in this case would be all real numbers. Our end behavior, it would be approaching 1 on both sides there. That is graphing some rationals. Next class, we'll get into graphing some more of these with more parts.